had a lot of pictures of black rocks over the last couple of weeks.
That's a very niche Instagram account, right?
You're listening to The Cosmic Cast.
Hello, and welcome to another episode of The Cosmic Cast, brought to you from the Earth and Solar System team at the University of Manchester. I'm joined by our usual array of co-hosts of Ricky Bahir, Elliot Carter, and Marissa Lowe.
Hello.
Hello.
And almost a year to the week, back once again with some incredibly exciting news. It's Dr. Ashley King from the Natural History Museum.
Oh, hi.
How's it going?
I'm good. I'm very well, actually. Very well.
Fantastic. So, I mean, we've invited you on today because I thought it'd be absolutely fantastic to talk about the really exciting news that for the first time in how many years is it? I guess decades, that we've recovered a UK meteorite.
Yeah, so this is the first meteorite recovered in the UK for 30 years.
30 years,
wow.
Fantastic.
Last one was, I think it was in the summer, 1991, the Glatton meteorite fall, which is near Cambridge, I think. Yeah, because they don't come along very often.
Yeah, no, it's really exciting. And so this is, we were just chatting a bit about off air. So it's not been officially classified yet, but it's going to probably be known as the Winchcombe meteorite.
Yes.
So it was found in Gloucestershire, I guess.
Yeah, so just to the northeast of Cheltenham in Gloucestershire. So you're right on the edge of or just into the Cotswolds, I think, is this little quite sleepy town, I guess, of Winchcombe.
Mm-hmm.
And so that's where the biggest amount of material that's been recovered so far was collected. And so, there's an official classification process that we're now starting where we'll look at the mineralogy and the chemistry of this. And then that goes off to the meteoritical bulletin, and then we'll have an official name. So, it's very likely in the not too distant future, it will be known as the Winchcombe meteorite fall.
Yeah. I guess all this process is just a sort of a formality at this point, really. I suppose looking at it, you can tell instantly that it is definitely a meteorite.
Oh yeah, it's a meteorite. Definitely a meteorite, and it's definitely a carbonaceous chondrite. And it's looking like we have a little bit of preliminary work. So it's looking like what we call a CM or Mackay type carbonaceous chondrite. So these are the ones that have kind of really simple organic type materials in them, and also minerals that were formed through water rock interactions in the early solar system. So they're really exciting rocks. They're the things that I've spent most of my career studying. So this is a doubly exciting event for me to get one of these actually falling in the UK is amazing. Yeah,
and that's an incredible thing to have happened, really, isn't it? I suppose it's something that you directly researched to actually to fall on the ground. So perhaps we could sort of backtrack a little bit then. And so, I guess it'd be worth stepping through the process of, how did you actually track this thing down in the first place? I guess it starts off with the sighting of a large fireball over, I guess it was seen in most parts of the UK, wasn't it, really? It was that bright.
It was seen all across the UK by just eyewitness accounts. And you can actually, if you see a fireball, you can report it to the International Meteor, what are they called? Meteor Association, or I can't remember the IMO. So it must be observatory or something. So you can actually go online and say, I've seen a fireball. And this event that was on the 28th, just before 10 o'clock on the 28th, 10 p.m. On the 28th of February, was reported by over 1,000 different eyewitness accounts from all over the UK. And I think it's the highest number of reports they've ever had for a fireball, actually, on that website. That's partly because it's the UK, so there's lots and lots of people around, obviously. Yeah. And it was seen all across the UK. I think people in some of mainland Europe also, sort of in the Netherlands and things, also reported this thing.
Oh, wow. And so it was very bright then.
It was, magnitude was about -8, so it was pretty bright. Not the brightest you can get, but bright enough. What the advantage was that we had really clear skies, I think, all the way across the UK that night.
Yeah.
And I don't know who's out and about at 10 o'clock on a Sunday evening, but apparently lots of people were. As I said, the weather was very good, so I think that obviously helped. And so we had lots of eyewitness accounts. We then also have our dedicated camera networks that are designed to do this and track these things. So we have 6 or 7 different camera networks in the UK. All using slightly different cameras, but all watching the skies and recording these meteors and these fireballs as this material comes in. and we all operate under the UK Fireball Alliance is what we decided to call ourselves. It's kind of a brand name for all the networks, and all the networks picked it up on that Sunday evening. I went to bed that night having seen some of the footage and thought, there's a chance that we could have meteorites on the ground. We could see that it was going, it was big and bright. It was going quite slowly for a fireball, so it was about 13, 14 kilometers per second, which is at the lower end of a kind of fireball. They can go up to sort of 70 kilometers per second. So we knew it was slow. We could sort of see fragmentation, but none of that's kind of a guarantee of meteorites on the ground. But we kind of thought there's a chance. So yeah, we woke up on the Monday morning and decided UKFall has been going. The camera networks have been operating for many years now, some of them, but UKFall kind of has existed for 2 or 3 years now, I think. And we kind of already had a press release ready for any event that might happen. And we decided on the Monday morning that we would get that out there and say, yes, we think there might be meteorites. If you find some weird rocks in your garden, please let us know. So that was our first kind of approach to trying to find some meteorites.
Yeah. Is it quite hard? Sorry, Marissa.
I was just going to say, from an outsider's perspective, it just seemed like it suddenly blew up on science Twitter. Suddenly everyone was sharing the photo of a sort of rectangle of the UK, where I guess triangulated where it could be. So based on the cameras and the eyewitness reports.
Yeah. So we knew from the cameras we had a pretty good idea, and we as I said, we had a draft press release. So all we did was just plug in the numbers, the data that we had from the networks. And Jim Rowe, who kind of leads the UKFall network, he estimated a rough strewn field. So the original maps that went out have a kind of it's a really big area just sort of to the north east of Cheltenham. But it's not a searchable area. So that wasn't any sort of official strewn field. It was just, what happens is the fireball comes in, any meteorites that fall should be in a straight line after that fireball. If you ignore all the weather and everything, they should be in that area. So we just said, this is the rough area that it will be. And we, as I said, the weather was really good. So there was no wind. So these things can get blown off course. So what you have is, when the object comes in, you have that fireball, really bright, and lasts for about 6 or 7 seconds, this one. But then when it goes out, we lose track. We don't know what's going on. And that object is still maybe 20, 30 kilometers up. So you have what's called the dark flight period. Sorry, apologies. So you have this dark flight period where we can't see what's happening. And if it's windy and you've got little bits of carbonaceous chondrite coming down, they could easily be blown off. So we put out an area and said, if you're in this area, give us a shout. But sort of behind the scenes, we had people, so the Global Fireball Observatory over in Australia, for example, were processing all of those video images to actually narrow down that strewn field for us. So that was kind of Monday. We were saying, send us black rocks, pictures of black rocks. And that's been great. I've had a lot of pictures of black rocks over the last couple of weeks.
That's a very niche Instagram account right now.
Lots of people sending them in. I'm not a complaint at all. It's been good. But because of the lockdown restrictions, we couldn't immediately just go and search.
That must be quite frustrating, actually.
Not practical for searching. So in the background, we were trying to narrow down the search area, the strewn field. And once we had that, we were kind of planning to go towards the end of that week, hopefully, to get some small teams out there. There's a lot of paperwork and risk assessments and things that were going on to do that. We just got lucky that it hit someone's driveway.
Well, yeah, I was going to say, because I mean, I guess, considering, how sort of wooded and all the fields and stuff, that must have been incredibly challenging to try and search that kind of sort of terrain, I guess.
Yeah, so I actually didn't end up on any of the searches because it hit this driveway. So I kind of was able to get over there quite quickly to meet the family. And I was going to search on the so everyone else sort of came down on the Wednesday evening or Thursday morning to start the searching. And I actually got hold of the first material that was recovered on that Wednesday evening after the fireball. So that was a very weird, very strange, in my hotel in Cheltenham with a bag of black rocks, and there's nowhere to go, nothing to do, and it's just a very strange experience. And Natasha Stephen turned up, so I got to at least I got to tell someone and chat to someone about it a little. And And then the search, on the Thursday when the search teams came down, I got out of the car and it was very cold, and we decided it was probably important to get the sample into the museum as quickly as possible and curate it. So I actually came back and missed out on searching. But yeah, it's not. Yeah, you're absolutely right. It's really tough to find meteorites in the UK. It's not a desert. It's not completely white. It's not. They're all the same color. You're looking for small black rocks in a field full of sheep poo.
Yeah.
And if you talk to the search team, they can tell you all sorts of fun that they had traipsing around these fields.
Yeah, I'll bet. Because I guess for context, the fragment that was recovered was probably what kind of size? Like smaller than a fist, I suppose?
So that's good. So the initial material that was recovered, we got about 300 grams from the Wilcock family drive, and I don't know if you've seen the pictures of the splats that this made. So we got those photos. They actually contacted us on the Monday evening. We got those pictures, and we looked at it and thought, yeah, it could be a carbonaceous chondrite thing that's hit it, but the way the material was piled up looked a bit suspicious, and we weren't quite sure. And because you couldn't just get on a train and go and look, we kind of said, well, okay, we'll wait until later in the week and we'll chase it up when we're actually over in the area. So in total we've got about 300 grams roughly from them. And so what's happened is the rock has hit the drive and just exploded into loads and loads of tiny fragments. So the biggest one from there is probably about 20 grams or so. So I guess the sort of size of a golf ball or something like that. And then we've got thousands and thousands and thousands of grams. And then we've got like 40, 50 grams of powder, just powder that's piled up. And that's really interesting. We don't know if that powder was it a different lithology within the meteorite, and that's why it's powdered, and all the other things have stayed as kind of as rocky fragments or not. And that's one of the things we'll look at. And there's a tiny little dent in the driveway as well, which is really amazing. So when I got to go over and see it, it just looks like a little mini impact crater. Really
excellent.
Amazing.
The Winchcombe crater as well. Fantastic. They're going to have lots of disgruntled geologists coming along and having a look now. That's amazing. I remember the sheer, the odds of having something, land on something easily spottable as a driveway. I mean, that's just insane, isn't it? I mean, if it fall into some person's field, I'm sure the chances would have been much hard to find.
Yeah, we got that. Yeah, it's incredible, and we're so lucky that happened and that they realised quite quickly what it might be. So Hannah, the daughter, heard a bang after the. They didn't see the fireball because they're just in their house and stuff. But she heard the bang from the rock hitting the driveway. But she said she described it as being kind of like, if you imagine like a picture frame falling out of your bedroom window and hitting the floor. So it's not massive, but a definite bang. And kind of, it's dark outside. You don't really go. It's 10 o'clock on a Sunday night. You don't go traipsing around to find out what that was. And then they woke up the next morning and they saw this splat of material on their drive that wasn't there the day before. And so they kind of, it does look like, and I've seen other people describe it, it does look like somebody's just tipped up their barbecue. Really like that. And they thought that's very unlikely to be the case in February. So they kind of sort of thought, well, the only place this could come from is the sky. So Rob actually bagged up a significant amount of that material, probably within 12 hours of the fall. Really, really quick. And then over the next couple of days, continued to search his front garden and find these tiny. I say he found some of the bigger bits, and then when me and Sarah Russell got there, we then started picking out the really small bits in his front lawn. So it just kept coming. You could spend weeks and weeks there trying to retrieve material. So we were really lucky that they, realized, they didn't know definitely it was a meteorite, but they realized that could be a possibility, and they didn't just sweep it away. That's really lucky. And then the other thing, so we got 300 grams from there. I would say the total mass of recovered meteorite, and there's still a little bit to come in, is probably getting towards 0.5 kilo now.
Oh wow!
Okay.
We have other residents in the local area have found nothing as big as the 300 grams, but they found smaller stones on their driveways, on their lawns, and they picked them up and realized, they've seen all the press that's gone around, and so they got in touch. So we have, some smaller stuff coming in, and then the Glasgow, the team from the University of Glasgow, led by Luke Daly and Anya and Lydia Hallis, they did a really great, thorough job, and Katie and Roma from Manchester were there, and a few others. They really traipsed around those fields for like 4 or 5 days, and they found a absolutely beautiful stone, which is about 150 grams or so, and it's broken into two, unfortunately. But it's a stunning fusion crusted stone,
cool.
and it's just so black and dark inside. It's incredible. So yeah, so they actually found some unfortunately, I wasn't there for that, but after walking around in the cold and the drizzle for 3-4 days, to actually find something.
That's a good reward, isn't it?
Amazing. Yeah, there's some great videos and pictures and stuff of them doing that. So yeah, and I suspect that there was probably more material out there. Probably not big things, but probably small stones. And just if you're looking for a gram or something of material in a field, I mean, good luck.
Well,
but if it lands on your driveway or in your garden, it's really dark material. It really stands out. Even on the driveway of the Wilcox, it's a driveway. It's a dark grey colour, and this material really stands out. It's much blacker than that. Yeah.
I guess you've kind of hinted at it there, but you said there's very little doubt it is a meteorite. So looking at it, what kinds of things, for those that don't know, like what kinds of things are telling you that?
So there's a fusion crust. So that's so I don't know if you've seen some of the pictures. So many of the fragments are partially. So there's that really nice stone that the Glasgow team found, which is entirely fusion crusted. A couple of the other pieces that have been found in gardens and things have really nice. They're almost entirely fusion crusted stones. And then the stuff that we collected from the driveway, most of the fragments, I would say, have some sort of fusion crust on them. So that's a good sign. When we did all the press on the Monday, we kind of tell people to look for a black, shiny looking rock with a smooth outside, and it might feel kind of dense because, we think most things are going to be ordinary chondrites. We never dreamed of a carbonaceous. So this is kind of the opposite. The fusion crust is black, but it's not super shiny like you would get, say, on an ordinary chondrite. And the material is just very, very light to handle, so it's a bit different. And then, just looking at it, it's just how to describe it. I think there's almost nothing in it. It's just really fine-grained, black, dark material, and it's incredibly fresh. So normally these things start reacting with the atmosphere immediately, and they'll lose some of that kind of dark color to them. And I don't know how to describe it. It's like I've seen so many carbonaceous or CM chondrites in hand specimen. It kind of, you just know. We didn't know it was a CM for definite, but that's what it looked like. I would say some of it looks kind of like CI chondrite material. So things like a Vuna, which essentially they're just 90% clay. They really don't have any chondrules or CAIs or anything in there at all. And you can see in some of the stones for Winchcombe, you can see features, bits that could be CAI or chondrules and things, but they're not big and obvious. It's not like looking at an ordinary chondrite that's full of chondrules.
So what was the sort of advice you were giving to people if they thought they had a piece of meteorite on their driveway? And what was the procedure that all of you went about for collecting the samples?
Yeah, so we were advising people to take a photo of it in situ, and if possible, write down whereabouts they were. If they could get GPS coordinates or something, that's really useful for us, because that, knowing where all the stones. So one of the tasks for us now is working out the location. We know where all the stones came from, so we can take that. We know roughly what the stream field was. We had the model, and the model was kind of really good, but not exactly perfect. I think. I haven't seen an updated model, but the original model estimated, I think, 50 grams of material.
All right.
We've got nearly half a kilo. So, what we'll be able to do now because of that is we can feed that information back into the model so that next time we do this, we can have a better defined stream field. So take a picture, record its location, and then, as best as possible, don't touch it. Because we're interested in things like water and organics in these meteorites and all meteorites really. It's really difficult to most people don't have a pair of gloves knocking around that they could use, but if you've got tweezers or tongs or something, and then either wrap it up into some aluminium foil or put it into a clean plastic bag, and then just get in touch with us. That was our plan. Just like send us a picture, let us know. We'll come around and sorry, my emails are pinging at me. We'll come around and we'll look at it in person if we can, or we'll get them to send it into the museum. So, and that's pretty much the process that the search teams had as well. So they had a whole load they had some sterilized bags, I think, that Katie Joy took down. But yeah, they had foil bags, I think they probably had some gloves as well, so they didn't have to handle it. And little GPS things so they could track where the material was collected.
And do you ask the public to perform mass spectrometry at home on it themselves immediately, or do you want to do that yourself?
They have the facilities available. It saves us a job.
Yeah, fair enough. Fair enough. Yeah.
And so what's one of the interesting things actually is we haven't had too much time to think about this, but one of the cameras that picked it up actually had a kind of diffraction grating on the front. And so we have some kind of a spectra, an element spectra from the fireball itself.
Wow.
And that really is I'm not aware of very many meteorite finds where that has been done before. So we can actually compare that to what the bulk chemistry is, and we can do some comparisons with the fusion crust. So that's going to be really fun. It's just one of the amateur camera people. I mean, so brilliant. The camera networks are partly institution-led. So like we do stuff. There's a camera up in Manchester. So the Manchester camera got it. We have it. We have that data in Cardiff and things. But things like UKMON, UK Meteor Observation Network, are mainly amateurs doing this, and people who are just really interested. But they collect amazing data that will help us with this. Yeah. So, but yeah, if people want to do their own analysis, go for it.
I guess that leads us on to, now you've retrieved the samples.
Yeah.
What's the plan with them?
I'm never letting them out of my sight ever
Okay.
again. I fooled everybody by saying send it to the museum and we'll look after it, and then I'll definitely give you some to analyze. But so it's currently just sat. I'm in the Curation meteorites collection at the moment, so it's just sat over there, sealed away in vials and bags and desiccators and oxygen scavengers and things. So what's really important for us as a sort of top priority is to get that material out of the atmosphere as quickly as possible, and that's really important for carbonaceous chondrites because they do contain things like organics and water and we're really interested in phases like salts, for example, that you don't normally see in meteorites. But so we know from Ceres, for example, there's all sorts of weird ammoniated phyllosilicates and clays, for example, as seen on Ceres. They've never been seen in a meteorite. But the thing is, if you don't get that meteorite really quick, ammonia will just disappear. So that's our kind of high priority science, is to try and preserve the material and start looking for these things that react really quickly. But then, our plan is to essentially have a UK consortium that works on this. So we're putting together teams. So we're going to treat it basically like a space mission. So this is almost as good as having a space mission. So the reason we go, and the reason we have missions like Hayabusa 2 and OSIRIS-REx to go to carbonaceous asteroids and collect material, is because we can go to an asteroid, we can characterize it, we can take the sample from a specific point on the asteroid, bring it back, and that's never seen the terrestrial environment at all, whereas all meteorites have to some extent. But because for this one, we've got material that was collected within 12 hours, so that's almost as good as a space mission. And because we have the fireball data, we can't say which asteroid, but we have a pre-atmospheric orbit. So we know whereabouts in the solar system it came from, roughly. And that's only been done for, 40 or so meteorites out of the 65,000 that we have worldwide. Wow. So it's really, really rare. And I think there's only one or two that's two. So there's only a few carbonaceous chondrites for which that's been done. So essentially, this is a UK sample return mission that didn't cost us anything. So that's going to be our approach to treating the analysis. I think, because we will, as you know yourselves, that we have real expertise and skills in analysing extraterrestrial materials in the UK. Yep. So our plan is to distribute all those samples across and into teams that will. There'll be a team that looks at organic materials. There'll be a team that looks at the mineralogy and petrography. There'll be a team that looks at curation, things like that. So we're putting those teams together now so that we can start doing some of the actual fun stuff.
I guess it's going to be a very well characterized sample at the end of all this.
It's going to be a very well characterized sample. So that's an interesting kind of debate we're having at the minute. So the initial classification, it's looking like a CM chondrite, but I mean, I've spent 10 years looking at CM chondrites, and I would suspect I'll spend the next 20, 30 years looking at CM. So they're incredibly interesting rocks. But, there are 500 or so CM chondrites. And just weirdly, over the last, 3-4 years, we've had a strange, weird number of CM chondrite falls. There's things like Aguirre Sarkas and Mukampura. there was another one. There's one in China. I can't remember all their names right now, but there seems to have been a sort of spike in the amount of CM material that's fallen to Earth, and being recovered as well, which is the important thing.
Are they all similar, or are they like, could you have destroyed one asteroid and that's all falling down?
It's really difficult to tell whether it's one asteroid or so CMs are breccias. Nearly all of them are breccias, and they contain lithologies that have all been altered to very different extents, and even some of those lithologies have also had some post-hydration heating. So they're incredibly complicated rocks to sort of piece together. And and generally, for most meteorite groups, and the CMs included, we often think of them coming from one parent body, and I've never been entirely convinced that we know that carbonaceous asteroids, there are loads of carbonaceous asteroids out in the main belt. So way more carbonaceous asteroids than stony asteroids, for example. So it makes sense to me that we've got CM chondrites that formed in a very similar time and place in the disk, but are coming from different parent bodies. Very similar parent bodies, but different parent bodies. And then what we know from things like Rugu and Bennu now is that lots of things are rubble pile asteroids. So they're probably in the early solar system, you probably had a big body, maybe sort of similar to Ceres, maybe not quite that big, where you had all this kind of fluid flow or aqueous alteration going on, and then that thing was smashed up and then reaccreted to make these smaller families of rubble pile bodies. And so that's why you could end up with bits of CM meteorite coming from all of those different things and all the different stages of alteration, as Helena. Potentially all just being mixed together as that material reaccretes. So it's a good question. We don't know really whether all the CMs are coming from one parent body or whether we're seeing lots of different parent bodies. It's but it definitely seems to have been a spike. I don't know if it's just so strange. It's easy to say there's been a sort of spike. There may have been just as many CM chondrites falling. They just all got in the sea or were never. Whereas it just happens to be these ones are landing on things. So I don't know.
Yeah. It's probably worth asking at this point why, you're particularly interested in this type of meteorite. I'm sure you would have been happy if any type of meteorite fell, but I feel like in the planetary science community, people were particularly happy that it was a carbonaceous chondrite.
Yeah, so this is the first carbonaceous chondrite ever recovered in the UK. So that makes it special. We have about 30 or 40 meteorites, Helena, in the UK? 40, I think she said. I should know that number. So nearly all of them are ordinary chondrites, and there's a few ions as well. So, and that's partly because if a carbonaceous chondrite falls in the UK and we don't collect it, it's not going to hang around in the atmosphere for very long. So that's part of the reason for that. And then, carbonaceous chondrites and CMs contain the thing I'm really interested in are the phases that were made by water rock interactions in the early solar system. So these bodies, the parent bodies for the CMs, probably formed in the outer part of the solar system. So maybe sort of, we don't really know where the snow line was, but sort of beyond 2 or 3 astronomical units away. So you had ice in the disk. There were chondrules and some CAIs, and then you have all the dust, and that kind of sweeps up and starts making bigger bodies, and you end up with your asteroid. But because you have ice, as that body gets slightly warmer from things like impacts and radiogenic decay, that ice melts and it reacts with the rock. So you've got evidence there's water there for the start. So, and one of the big things as planetary scientists we're interested in is why the Earth has water. Why did Mars have water or has water today? And same on the moon, and all of the inner solar system was probably too warm to have ice in the disk, but we know that water exists here, so it has to get here some way. So I'm interested in all those minerals that are made by that water rock interaction. What were the conditions of that? What was the composition of that water? Where did that water, the ice, was that ice interstellar ice? Was it ice that was made and condensed within our own disk? And then the other thing to add into that, which I guess I spend slightly less time looking at, but are the organic components. So you have really simple organics, you have alcohols, things like amino acids, ethers and things in there. So you have all the building blocks for your ingredients for things like life on Earth. And again, we have big questions about those organic materials. It's like, how much of that is interstellar organic material? That we know that there's stuff around other disks, and we know there's stuff in interstellar space. How much of it was synthesized in the outer part of the solar system? How much is one of the things I am interested in is how organics may have been synthesized as part of the process of the water up reaction. So you may have had some building blocks there to begin with, but they've been modified further by the fluid on the asteroid and stuff. So really complicated rocks. They're really fine-grained, dark. So to put, most people look at this and just go, it looks like a bit of coal. There's nothing really to see. But for me, it's just that they're just stunning. They're just, featureless rocks.
Brilliant. And so what sort of analyses do you think you might be doing personally then down at the museum then? And what, are you just going to be doing the initial characterization?
Yeah, so a lot of my own personal research has been doing things like X-ray diffraction. So to studying mineralogy, looking at the different abundances of things like the clays and the phyllosilicates, looking at the abundance of carbonates. So we get things like calcite. Sometimes we see dolomite in these meteorites, and they're really sensitive, really common minerals on Earth, and we know that they're really sensitive to things like the temperature of alteration and the pH of the fluids, and we can actually date how old those carbonate grains are. And then we have things like magnetite, which is really interesting. So again, that's probably a product of the aqueous alteration. It's probably metal forming that, but we can do some fun. So the paleomagnetism people can do some really interesting things and use that. If there's a kind of paleomagnetic record in a CM chondrite, you can also almost start working out whereabouts in the disk it formed. That's the really, really interesting thing, is to say, we know the CM parent body or bodies formed, there must have been ice. So we know it must have been beyond the snow line, but exactly whereabouts was that is really interesting. So so I'll be doing that. And then the other thing I'm hoping to be involved in is doing synchrotron work. So taking it out to places like the Diamond Light Source and using doing X-ray work, looking at things like oxidation states of iron, looking at so probably some organic work, doing carbon and nitrogen, looking at how it's bonded within the sample.
Fantastic.
Well, I see how you said you might be looking at this for the next however many years.
Yes, yeah, and it's amazing. There's so much stuff to do, really, and there's a kind of sort of classic sort of classification steps of doing the mineralogy and petrography and doing some bulk chemistry and things. But there's because we've got stones that were collected, for example, within 12 hours, and then we've got some stones that were collected the next day, and then we've got some material that was collected this week. We can compare, so we can look at how the material may have been modified in the terrestrial atmosphere in a quite systematic way that usually isn't possible for CM chondrites. So that would be really interesting. And then the other big thing for us coming up this year is the Rugu samples. The characterization of those will start in sort of May, June time, and we're part of the team for that. So it's going to be really exciting to compare fresh asteroid materials with really fresh meteorite materials and see what see what's similar, what's different there. And then in 2023 we've got OSIRIS-REx coming as well, this is probably going to act as a really nice analog for those materials and a really good way to test our procedures for handling those materials.
Have there been many cases where you have that sort of situation of you know when it fell, you collect samples however many hours later, a day later, a week later, and you can actually quantitatively see the effects of it being on Earth, being under atmosphere?
Yeah, there are. Yeah, so I think so. Murchison is always taken as the kind of most famous CM chondrite, although it's not the type specimen. Everyone thinks Murchison's the type specimen for the CMs, but it's Mackay. And so that was a really big, much bigger than this fall in Australia in 1969. But I think people still find bits of Murchison today after the event. So you can actually, so you can do stuff like that. So I sound awful. Curation is like sometimes it's seen as slightly less interesting science, I think. But because we have these sample return missions coming back, and plans for this feeds into OSIRIS-REx and Hybris 2, but also we've got new samples coming back from the moon. We've got stuff hopefully in the next 10, 20 years coming back from Mars. So these are really important things for us to think about for our meteorite collections: is how we curate, how we analyze, and preserve these materials, because this isn't just part of the reason we have a collection of meteorites and we do curation is because we want to do lots of exciting science with this material right now and today, but also in 10 years, 20 years, 30 years, when we've got analytical techniques that can measure things that we can't even imagine now, or we're trying to answer questions that just don't occur to us yet. This material will exist for long after I've retired. There'll still be people working on this, I hope.
Yeah. So I guess might be good just to sort of end briefly, I suppose, on this. So if people are watching this in a year or two's time, and then they happen to find something weird in the Winchcombe area, you still encourage people to get in contact with the museum and to submit
Absolutely.
stuff?
Yeah, always. Just send us. So at the minute, I'm trying to respond to things as quickly as I possibly can. Normally, it's not quite as hectic as this. But yeah, we'll always get back to people. So it's always great to send a picture in to begin with. So so lots of things we can rule out pretty quickly as not being meteorites, and then sometimes there are things that look like they could be meteorites, and we can organise to go and see it or get it to sent in. But absolutely, I never want people to think like they're bothering us. It's not at all. I've had lots of everybody. So I should say everybody in the local area and everybody who's been in touch with us have been absolutely wonderful to work with and deal with, and really great. And everyone seems really excited by it, which is fantastic. And that's exactly what we want. And so, I want people send an email and send me a picture saying, I think this is a meteorite. And I go, it's not a meteorite because, you're in the wrong area, or it looks like this type of thing. And but it's never a waste of time, never, not at all, because if we get just one that comes in that's a meteorite, that's really special for us. And I should also add that we kind of talked about the science for this, but the other really important thing is the kind of public engagement side that we're really looking forward to. So that plans for that are going ahead as well. Hopefully this material will go on display. We will go on display in the Natural History Museum in London, and hopefully we'll get some stuff out across the country as well. So we have to be careful with the material, and there are things about specialist storage cases and things. But there's a whole load of fun stories from the families and from the search teams and all sorts of stuff. And I'm really looking forward to going into schools in the area and being able to show them. This fell just down the road from where you live, and this is how we're studying it. And that's just as important as the science for us.
I'm sure there's going to be lots of future planetary scientists coming from Winchcombe now.
Yeah, let's hope so. Yeah, let's hope so.
Yeah, brilliant. But perhaps actually just one more thing that's popped into my head. So when will the next meteorite be, do you think? Is this a sort of a decadal event, looking at the sort of past numbers, or do you feel optimistic now that we've had this sort of network up and running, and that we might be able to recover sort of more things more frequently?
So we think that it's a really difficult number to estimate, but roughly we get lots of fireballs each year. We don't always see them because of the weather. So even though we've got pretty good coverage, the weather is not always in our favor. So most stuff probably ends up, meteorites do fall, it ends up in the sea. We're just not very big. So that's one of the reasons we don't get many. But probably there are a few small meteorites landing in the UK each year.
Okay.
By small, you're thinking sort of 10 grams or less. So not big things. And so I hope, in fact, I'm pretty optimistic that it won't be another 30 years until we get the next one. But the thing is, you have to, if you're looking for a 10-gram block, that's going to be a challenge. But with the camera networks, we could get the stream field down really, really to a nice search area. So we've got a better chance now than we ever have. So.
Brilliant.
But it does make life easier if it hits things.
Yeah, absolutely. Cool. Well, excellent. Well, in which case, then we'll look forward to seeing you again in a couple of years' time, talking about the next one.
My carbonaceous chondrite, I'm out now.
Brilliant. Ashley, thanks so much for giving us a bit of your time this morning and chatting to us. That's absolutely fantastic, and it's really exciting. I can't wait to see how this story unfolds. I suppose.
Looking forward to showing it off to everybody.
Absolutely.
Hopefully, when we can all start travelling around a bit.
Indeed. Absolutely. Fantastic.
Yeah.
Cool.
Good.
Well, Ashley, thanks very much. And for all you in the audience, if you want more Earth and solar system content, do check out all our social media links. We're on the Facebooks and the Instagrams and the Twitters and all the rest of it. You can find us mostly at Earth and Solar System. All the links are on the screen now and in the episode description. But until next week, we'll see you all very soon. And goodbye for now.
Bye.
Bye.
Bye.